Welcome to our next video. We're going to talk about multiplying monomials and polynomials. We've already talked about addition and subtraction. And you're going to find this isn't too difficult. It's just going to look terrible at first, but it really isn't bad. This is a review. What you see here is really just a review of what we learned in week 1 when we talked about when you multiply with the same base, you add the exponents. That's what we're doing here. So for example, A, you've got 42x to the second because we just added the two exponents, the 1 and 1. So these are going to look very similar. Remember, this whole presentation is in doc sharing. And for example, A and B on this slide, we're really using the distributive property. For example, A, we're multiplying x times the x and then x times the 7. And for example, B, we're multiplying 6x by x squared, then 6x times negative 4x, and then 6x times 5. And then we always look to see if we can combine like terms. In these two cases, they were fine. All right, so again, we have a monomial times a polynomial, so we're just applying the distributive property and multiplying the term on the outside by everything on the inside and then combining like terms if possible. Now, these are two binomials that we're multiplying, so I'm going to skip this for now and show you how to do this in just a second. Same with this. Now for me, I don't use the setup that you see at the bottom. What I do is multiply the first term by everything in the second set of parentheses, and then the second term by everything inside the second parentheses, and the last one by everything inside the second set of parentheses, and then I combine like terms. It's as simple as that. The solution you see at the bottom, that is the final answer you will get no matter how you do it. To me, that's a little bit confusing. I just like to do what I did just here with the green pen. All right, same here. I would multiply 3x squared times everything on the inside of the second set of parentheses. I would multiply negative 4 by everything inside the second set of parentheses, and then I would combine like terms. But this is really what I want to get to. Even though you will need to do every problem that I've shown you so far, this is a little memory device to help you multiply two binomials. So if you have a 2 by 2, this will help you. And FOIL stands for first, outside, inside, last. All right? So it's just a memory device to make sure you haven't forgotten anything, and it only works when you're multiplying two binomials. So here's the first term in each set of parentheses. Here are the outermost terms. Here are the innermost terms. And here are the last. And once you've done all that, you'll combine like terms and you're all set. So let me walk through this with you pretty slowly, and then I'm sure you'll catch on right away because it's so fun. I actually like it a lot. So I'm going to multiply first times first, first times first. All right, that gives me x to the third. So we've got first. Now I'm going to do outside. So these are the outsides. So x times 3 is 3x. We've got outside. Now I'm going to do inside. 4 times x squared is 4x squared. Got inside. And then last, 4 times 3, which is 12. Okay, and then we ask, can we combine like terms? In this case, we don't have any like terms, so we're done. But I do need to rewrite it so it is in descending order, and so that's what we did. So these are just FOIL examples. So just practice these. I would take this PowerPoint presentation and just go on scratch paper and practice these. Answers are right here when you're ready to check. You'll notice on example D we have the final answer written in ascending order. That's perfectly fine if it was given to us in ascending order. So we have two binomials in ascending order, so perfectly fine. Okay, the next thing here is a product of a sum and a difference. I am not going to suggest that you memorize that formula. Some people love formulas and love memorizing them, but I'm not going to suggest that you memorize that because it's still FOIL. So if you look at x plus 8 times x minus 8, and if you were to do FOIL, you'd get x squared plus 8x minus 8x minus 64, and that plus 8x minus 8x adds to 0, and that's why we have no middle term in our answer that you see here at the bottom. X squared plus 64 is the answer. Okay, but FOIL did it, so you didn't have to memorize this formula. You could just use the FOIL that you've been practicing with, and the outside and inside take care of itself. And then you have some more examples. And again, you can have a plus b squared, which means a plus b times a plus b, which means we can use FOIL. And you can have a minus b times a minus b. We can also use FOIL, and we don't have to memorize anything. Okay, so these three examples all use FOIL. What I want you to see, this is a huge mistake people make, and I don't want it to be you. X plus 8, parentheses, squared, does not equal x squared plus 64. This is incorrect. I'm going to cross this off really quickly. That's wrong. Okay, that's not what it means at all. Remember, when you square something, it means something times itself. Okay, so everything's not going to all of a sudden change. That is equal to, and this is correct, x plus 8 times x plus 8. And when you see something like that, I hope you're starting to think, oh, I've got two binomials. I can use FOIL, and FOIL will give us the right answer. So we don't have to use a new formula. We can just use the FOIL that we've been used to. All right, so this is basically a quick review of everything, but you don't need to memorize the formulas you see in the middle here. Just use FOIL if you have binomials. If you don't have two binomials, you can't use FOIL, but you still multiply everything inside of one set of parentheses by everything inside of the other. So let's take a look at these. Which ones can we use FOIL with? I can use FOIL for A, B, C, and F. Remember F, that's 2x plus 1 times 2x plus 1. I can't use FOIL for D, but I can still work it. I would just distribute that 3x squared times everything. And on E, I can't use FOIL, but I would multiply P through by everything inside the second set of parentheses. And then I would multiply 2 through by everything inside the second set of parentheses. And then I'd combine like terms. So even if we can't use FOIL, we can still do it. Right, so lots of examples. And even if you see more than one variable, nothing changes. So if you see an evaluate example where you have two substitutions to make, no problem. You can just make them and just use the order of operations. And even if you have a word problem, remember the word problem we did in the other video where we were talking about insurance rates or crash rates, I believe it was, if we had a 25-year-old driver and we just replaced the variable R with 25, right? This is very similar. We just have two variables we need to replace. No problem. Notice that little squiggly line. I don't want that to confuse you if you ever see it. If you ever see this little squiggly, it just means approximately equal to. And that means either we rounded somewhere or we had something like pi and we converted that to a decimal. Remember, pi is a decimal that goes on forever. So anything we use for pi, any decimal we use is an approximation. So that's why we use that. We talked about degrees already, and I told you already that you're going to be working with it a lot in Math 1005 if that's not part of your plan. But remember that the degree of a monomial is the same definition as it was before. It's the sum of the variable factors of a term. So the variable factors we see in 10x to the third, y to the second is, well, 3 plus 2 is 5. Okay, so we've got that. On the next one, it's 3 plus 4 is 7 plus 1. Don't forget that implied 1, so that's 8. And then we've got 1 plus 1, which is 2. We've got 1, we've got 2, and 0. So all of these are correct, of course, but those are the degrees of each of the terms. If you want to know the degree of the whole polynomial, it is the largest, and that is 8. All right, like terms, it's a huge idea. If it's anything that you've had trouble with at all, please get it worked out in your mind. You can only add or subtract terms with the same variable or variables to the same power. So I can add w fifth y to the fourth and w fifth y to the fourth, but I can't add x squared y and xy third. Okay? So these are some really good combining like terms examples I do encourage you to look at. And addition or subtraction works like we talked about before. We just have to add or subtract only like terms. So I will leave these examples to you. And then this multiplication problem, I'm asking myself, is it FOIL? It's not, but I can still multiply. And what would I do? I would not do it the way you see at the bottom. That's just me. I'll leave it there for you to look at. But you just multiply this term by everything in this set of parentheses, and this term by everything in that second set of parentheses, and then that term by everything in the second set of parentheses. And then combine like terms. All right, so a review. What can we use FOIL with? We can use FOIL for A, B, because that means 5x plus 7y times 5x plus 7y. We can use FOIL for C, same reason. We can use FOIL for D. We can use FOIL for E, but we can't use FOIL for F. So for F, we would have to multiply each term inside the first set of parentheses by each term inside the second set of parentheses, and then combine like terms. So all of those are worked out here. And the next topic we're going to talk about is division, so that'll be on the next video. Thanks for watching this one.